at arc length and unit conversions today. This is a relatively easy one, so I just kind of want to give you an introduction a little bit. We're going to talk about arc length, which is basically part of a circle. So if you went around the entire circle, you've got circumference. In this example, we're going to be talking about just a piece of it, right? So part of the circle would be considered an arc. So we're going to talk about how we can find the distance of that arc. In the second part of this, we're going to talk about how to take units like miles per hour and convert those into things like radians per second. So we're going from linear speed, miles per hour, going in a distance over a certain time, versus angular speed, so revolutions or rotations, things like that per minute or per hour, per second. So it's basically going from linear speed to angular speed and back. Let's get into it. Here we have a circle, or in this case, pizza. All right, so you have this entire circle here. The question is, what is arc length? And what we'd like to know is the distance around this is considered arc length. The question is, we really want to take this pizza slice and we want to find if this is 60 degrees. Then we need to find out what the perimeter, right? Perimeter would mean if I take the pizza slice, if I were to find all of the sides of this slice, all the red sides, then I would have the perimeter. So if we kind of take it out of context, we're going to go ahead and bring this out. So if we just kind of draw this out, it looks something like this. Right? So you have you have your radius of 7 here, which means that all circles have radii that are all the same length, right? So that would mean that this is also 7. So I'm going to go ahead and label this, since perimeter would be adding all 3 of the sides together. So this is 7, this is 7. I don't have this. We're going to call this S for now, for arc length. We know that this is 60 degrees. And I have the formula for arc length right here, okay? However, we know that the theta in this example is exactly, in this particular form, it has to be in radians. That is not in radians, so I cannot use the formula that I have written for me. I've got to convert that back over. So that's the first thing I'm going to do, right? So theta in this example is equal to 60, but I need that theta to be in radians, not just degrees. So to convert from degrees to radians, we multiply by pi over 180. The reason is here I need my, when I use my formula, whatever I put in the top of the fraction, that's what I'm going to end up with. Since pi is a radian measure, I'm going to leave it up there. 180 degrees is degrees. If I were looking for degrees, I'd put this one on top. So if we multiply through here, you're going to get that to reduce. 60 goes into 61 times, 60 goes into 180, or 6 goes into 18, 3 times. So we end up with pi over 3 as my radian measure. So we know that arc length, that S, is going to be equal to 7 times pi over 3. So that's going to end up, and I'm not going to simplify that, it's 7 pi over 3. Now that's S. Now be careful, that is exactly just this piece. A lot of the times I'll have students say, oh, look, my answer, 7 pi over 3, I used the formula. Yes, you did, and you used it correctly. However, that wasn't what the question was asking. So we're going to go back in. Perimeter is going to be 7 plus 7 plus 7 pi over 3, or actually I like to write it like where it's an improper fraction, where you have it all at one fraction. So 7 pi over 3, just like this. And now we fully expect this kind of thing to be a decimal value. So what we're going to do is we're just going to add that up. So 7, so it's going to be something like, it's going to be more than 21, right? So 7 plus 7 plus 7 times pi over 3. Actually, maybe a little bit less than that. So 7 plus 7 is going to be 14 plus 7 times your pi over 3. Yeah, and so we end up with 21.33. Let's see, this is in inches, is the perimeter of this pizza slice. Now remember, I used my formula. I converted the angle measure to radian measures, and then I plugged it in to find the actual value for S. And then I found the question's answer, but it was about perimeter, so I added all three sides together in this example to get 21.33. Okay. Number 2. Here we have an exercise in just converting from units from one thing to the next. This is relatively easy, in fact. If you just let your units kind of follow along, then I can actually just line up the units and everything's going to cancel out, right? So if I'm wanting to go from 30 revolutions per minute into miles per hour, I need to know a few things. Number one, going from minutes to hours is a relatively easy thing to do. So I'm going to do the easy stuff first. Let's go ahead and set that up. And so if I want to convert this, I need to get rid of minutes and go to hours. We know that's a really easy thing. 1 hour is equal to 60 minutes, right? So the minutes cancel out. If I were to multiply through right now and leave it alone, I would end up with 30 times 60 revolutions, so 1,800 revolutions per 1 hour. I don't want revolutions, I want miles. Revolutions, so one of the things I can remember is that 1 revolution is the same thing as 2 pi radians, right? We also know, and this is another thing, that pi is the same thing as 180 degrees, right? So there's your radians to degrees. This is your revolutions to radians. I could also do 1 revolution per 360 degrees. These are the same things, right? These are conversions. These are equal pieces. One thing that you may not know is this one. One radian is equal to 1 radius. Now that one is important. If you aren't writing anything down, this is the one you need to write down, because this one is not so, I remember this from the past, right? This is something new. So this one converts from linear distance, that's the radius, to angular distance, right? So radius is in a distance, it's the radius of the circle. A radian is an angle measure. So 1 radian is equal to 1 radius. Now be careful, the 1 radius here changes based on whatever the radius of the circle is. In this example, 1 radian will always stay the same, but here we have a wheel of 36 inches in diameter. That would tell us that our radius here is 18 inches. So that's going to be important. That'll come in a little bit later. Okay, so we're good on hours. I've got the hours set up. Let's get to miles. First, we're in revolutions. I got to go from revolutions to a distance, right? So we know that 1 revolution is equal to 2 pi radians. And I can go from radians to radius. Now, I went straight to radians. I did not go to degrees because this formula here uses radian measures. And so I'm going to do that. I'm going to put the radian down in the bottom. Remember, what I'm doing here is I'm canceling this out. So, right, so we had a revolution to cancel out here, and it cancels it out there. So we know that 1 radian is the same thing as 18 inches. Now, be careful. Notice that I wrote this, whether I put radian on the top or radius on the top, whether I put revolutions on the top or radians on the bottom, I can flip these over and it's exactly the same thing, right? Pi on the top or 180 on the top, it won't matter so long as I make it cancel outright. So here, we're still getting our radians to cancel. So now if I left it, I would be in inches per hour. I don't want inches, I want miles. And so now it's a really easy thing. If you remember, maybe you don't remember this, so you might want to write some of this stuff down. We know that if I'm going to cancel out inches here, we know that, and I want to go to feet because I know feet I can get to miles. We know that 12 inches is the same thing as 1 foot. So I'm kind of following my nose kind of as I build these up. The one thing that you kind of skipped a stretch is it's this piece here, right? It's going from these two. So pay attention, and we'll do a couple of these eventually, so you'll get used to it. Now I need to go to miles, right? I need to end up with miles here, not minutes. M-I-L-E as miles. And I know that if I had 1 mile and I want to get rid of the feet, that's 5,280 feet. If that wasn't in the back of your mind somewhere, definitely write that down. And so let's just check it out. So I've got my inches canceling, my feet are canceling, the units that I am left over with. Okay, on the top we ended up with miles, and on the bottom we ended up with hours. And that's exactly what I wanted to come out with. Now, bit of word of thought here. When I'm going to multiply this together, I'm going to multiply the top together, and then I'm going to multiply the bottom together. I don't want to do this separately, or I don't do this all at one time. There's a lot of opportunities for me to mess up. Once we get all the math done, if you multiply the 630 revolutions times 60 minutes times 2 pi radians times 18 times 1 times 1, we end up with 1,360,800 pi divided by 63,360. Do that math, we end up getting 67 point, we'll round it to a tenth, miles per hour. Always take a minute to make sure that your solutions make sense. Right? You have a truck's having a fairly high revolutions per minute, so we would expect that to be an average speed. So if you were to get something like 300 or 0.5, you know that doesn't make sense for a truck to be traveling at those different speeds. But 67.5 miles an hour seems very reasonable. And that's something you always can do with math, is make sure your answers make sense. Okay? Remember, when you're doing this stuff, remember your conversions. Remember those pieces. A few things to remember from this one is this scenario here, and where we have the revolutions and the radians, the revolutions and the degrees, the 5,280 feet in 1 mile, and all the other stuff. So make sure that you get this down, pay attention, and I hope this really helped out.